BSD is good.
Huh? BSD is good. It's really good. But I think it's a little bit difficult maybe for beginners. But FreeBSD is really good. FreeBSD is the Linux operating system that is most like Unix, I think.
And most people say BSD is more stable than
BSD is also the most stable one. BSD is the operating system that they use on the International Space Station. Did you know that?
And Berkeley University.
Berkeley uses BSD as well, did they?
They created.
Oh, of course, Berkeley created. The B is for Berkeley, isn't it?
Yeah.
In BSD. Yeah. So, I mean, I think don't mention Windows at all.
Okay.
This is my advice, okay? Nobody cares about Windows. I don't care about Windows. Don't mention Windows.
Okay.
Make your presentation, don't even call it operating systems, because this will make the EAP teachers feel like it's too general. Call it something like, you know, an overview of Linux, or the history of Linux, or, you know,
Okay, that's nice.
you could have Linux, the biggest operating system you never heard of, because your phones, Androids, they're Linux, aren't they? A type of, a version of Linux. But most teachers wouldn't necessarily know this. So I'd say, if you want to go operating system, go Linux route. So put something in an email, and then copy Connell and Dennis in on it. You know what I mean? And then that way I can reply to this email, and if it's good, I'll give it a positive recommendation then. Sounds fair?
Where was Tuvalu?
Huh?
Where was Tuvalu?
Say what?
Like, where was created Linux?
Oh!
1990.
The 70s, isn't it? No, it's a little older than the 90s, I think.
Asking where, not where.
Where I thought Linus is from Sweden or Norway.
I think he's Finnish.
Yes, thank you. He's Finnish. That's right. He's from Finland. Linus, who invented Linux, is from Finland. Very good, and he still works on it. He writes most of the code still.
He's still alive?
No,
Yeah,
he's,
yeah.
he's trying from the coffee. He's saying he's still writing.
Just plug the USB key into the coffin and give you the update. Yeah. All right. So let's continue with vectors then. So we have something we're going to look at called the dot product.
This is the homework.
Not too difficult, right? Except maybe the last one. No, the last one was easy too, wasn't it? Yeah, it's easy. Okay. So far we've said that you can add vectors, subtract vectors, multiply them by a scalar, but right now we have, actually the full name is Scalar Dot Product. Right now we don't have a way to multiply vectors. So for example, if you have vector R1, which is x, y, z, and you have vector R2, or let's say x1, y1, z1, and R2 is x2, y2, z2, you could multiply this by a number, true?
Mm-hmm.
You could add these together, true?
Mm-hmm.
But you can't multiply them.
Not yet.
Not yet, until today. So, we have this thing called a dot product. And the definition of dot product of two vectors is you multiply the I components plus you multiply the j component plus multiplying the z component, the k component together. Now please notice, you start off with two vectors, but you don't finish with a vector. What do you finish with? Is there any ijk here? Any vectors? Any brackets? No. This is just a scalar. It's just a number. So dot product, or scalar dot product, takes two vectors and returns a single valued scalar. Okay, let's have a look here. Yeah, now the next lesson we'll see more of the applications. No, and in fact the next lesson is really what the applications are for. Let's do an example. Can I scroll down?
Mm-hmm.
Yeah, so we'll have No, it's okay. Let's do it. No, it's okay. It's okay. It's all cool. Right. Let's do an example. So if I said vector A is the vector 2, 1, minus 1, and the vector B is the vector 3, 2, 1, then, now, no, I don't think I've said this explicitly, I might have said it in passing, but usually when something is a vector, to represent it's a vector, we put little arrows on the top. Now, I don't always do this, because in the exam, they don't. They shouldn't. They're not supposed to. Sometimes they do. This is part of the problem I have with the exam, because it's written by different people. But technically, the notation in the exam that they're supposed to use is bold font. So if it's written like this, it's not a vector, it's a scalar, like A equals 2. But if they use bold font, which is hard to draw, you know bold font, then it means it's a vector in the exam. So if it's bold font, it's a vector, okay?
That's not good.
No, well, it's hard to write bold font, so I'll use arrows, okay?
I know it's bold font.
Hmm?
I know it's bold
Mhm.
font. But you know, when you're doing exams, sometimes you won't, like, you
Mhm,
know
yeah.
that font.
No. Okay, so dot product these two vectors. It will be 6 plus 2 minus 1. So what's that? 8 minus 1, 7.
That's all.
That's it for dot product. Now, there's a little bit more to do, but just I want you to practice 3 examples like this. So can you see in number 1, there, I just want you to practice, we'll say, AJK. Or if you want, AKJ. So if you can try, if you can try these. And then together, I want to do number 2 together.
So for one, AJ.
Just practice AJ and K, and then we'll do 2 together. Do we have a class of 4? Yeah, okay.
Tutorial.
No, we're converting the tutorials into lectures to finish the course sooner so we can have more revision time.
By the way, can we-
But if there's a question you want me to do, I can do it in the class.
which one is it?
A KJ. Please do 1 KJ of questions. A, K, and J. Takin, can you move the projector to the right a little bit? Great, perfect. Have I got enough battery power? Just about. Yummy, get off the phone. You don't have your calculator? Oh, okay.
Even K is alone, which is then multiplied with
Huh?
J.
In J?
Yeah.
Let's see. Which one's J, Fahad? I can't see. This last one.
No, not the last one.
Second last.
This is the last one.
I can't. No, which one's J? J. You have. That's L.
Oh,
Yeah, in this one, there's no K, so you can just call it 0K.
0K.
Yeah.
Everyone's now seeing
Straight.
Now You See Me. I don't think so. Who's in it?
I can't remember the name.
The movie was literally good.
Like the movie
Now You See
defying
Me.
the law, destroys the law of physics.
Yeah. It's a sci-fi movie?
Oh.
No,
Like a magician.
Horror?
No.
magician.
Magician.
I've seen The Illusionist and The Prestige, isn't it?
This was a series, yeah?
Oh, the series, is it? Not
No,
movie.
this one is not series, the movie, just the movie.
The part 2 is coming now.
Yeah,
like
the part 2 is coming now. You should-
Movie in the cinema or on DVD?
On DVD, because it's old.
It's old one.
But
Yeah,
it's
so a new one is
14.
coming.
Oh, there's a sequel.
Yeah,
You recommend it?
yeah.
What's it called? Now You See Me.
Now you see. You'll be stoned.
Yeah?
Because
Yeah,
they
you
let,
should watch
they let
it.
everything happen, the impossible happen, and you now explain it like after.
Cool. All right. Okay. Don't say any more. I'm going to watch it. I'm going to watch it.
Wrote it down.
Yeah. No, I remember it. Now You See Me. Because I watched the. Have you ever seen The Illusionist?
I don't know, but
Again, it's a similar thing. It's a movie, magic movie. You know, about a magician. And again, like what you're saying, is a lot of stuff happens in it. And also, there's another movie which is about a magician as well, actually directed by, what's his name, Christopher Nolan, called The Prestige, I think it's called. And also about a magician, but a little bit more sci-fi. Yeah. So you're saying this was kind of like one of those types of movies?
yeah.
Yeah. I really like The Illusionist.
It's a,
It's good.
yeah, it's really good.
You saw The Illusionist? Yeah, it's a good movie. I'll watch this one now. Now You See Me, and I'll tell you if you were right, if it was good or not.
It's good. I have seen it. No,
Yeah?
Yeah. it's
Oh
good.
yeah, but maybe I don't trust your opinion. But I'll definitely watch it. I'll definitely watch it.
Just see, I suggested Kali Linux. So you should.
But I knew about Kali Linux already because I used to use Backtrack.
Okay. So what about that mobile thing?
It's true, but that's not a movie.
That's not.
Maybe your taste in movies is no good.
Well, our taste in movies are not the same, but we both agree that this movie is great.
Okay, then we must be onto something. And I suppose you do like Flash and Arrow,
Yes.
so this earns you some points then. Alright, have you got those three finished?
Yes.
Yeah, so let's have a look at number 2. I want to do it together. That's okay, I can see it. Can I go down?
Mm-hmm.
Right, so in number 2, you have A. They don't tell you what, I don't tell you what it is because it's just something in general. So I'll call it, no, number 2? Oh, I give it to you, don't I? Yeah, sorry, what's A there, Fahad?
AI
Yeah.
minus J,
How many I's?
just
One I, yeah, minus J,
minus 9K.
minus 9K. And then B,
2I
yeah,
minus 3J
yeah.
minus 9K.
So like this, 2 minus 3 minus 9,
Yeah.
1 minus 1 minus 9.
And C,
Oh, there's a C, okie dokie.
I,
Yeah,
J
yeah,
plus 9K.
like this.
Yeah.
Okay. So I'll do one and then you can try one. So again, we want to say if it's true or false. So we want to check if A dot B equals B dot A.
It's not true.
No, not necessarily because it might, well, we don't do matrices anymore, but
Matrix.
yeah, for people
Change the sign to
with matrices, it's not the same. So we don't know, but it will be the same. But there's no reason to assume it'll be the same. But we'll check it with these as an example. So A dot B, 1 minus 1 minus 9 dot 2 minus 3 minus 9. Does that equal 2 minus 3 minus 9 dot 1 minus 1 minus 9? Yeah, because here we'll get 2 plus 3 plus 81. Does that equal 2 plus 3 plus 81? Yeah, it does. So this is true. Do you think it's always true? Or just for this example?
maybe just make it. Because sign is because it's
No, in fact it's always true. It's always true. Not just in this example.
oh, yeah.
Yeah? Okay, so I'll do the second one, but I want you to try it first. So what do I ask you to check in B? Does A dot A equal the magnitude of A squared? Okay, see if that's true or false.
Magnitude of A squared.
Yeah.
No, square of the magnitude.
Magnitude of A, then squared. Yeah, square of the magnitude. Yes. Okay, so what are we looking at here? It's the magnitude of A dot
Yes.
A equals magnitude of A squared. Okay. Where's my pen gone? I can't see it. Here we go. Come on, turn on. You can do it. There we go. Right. So in B, A dot A, that equals 1 minus 1 minus 9 dot 1 minus 1 minus 9, which is 1 plus 1 plus 81, yeah? Which is 83, is that right?
It's false.
No, hang on, is that part right?
Yeah.
Yes, it's true.
Yeah. Now, next we need to get the magnitude of A. So the magnitude of A would equal square root 1 plus 1 plus 81. My pen went out again. Come back. You can do it. I believe in you. There we go. Okay. So that is root 83. So what's the magnitude of A squared? 83. So are they the same? Yeah. So this one is true. Do you think it's always true?
I think so. No.
This one is always true, not just for this case. What's wrong, Fahad?
How is the sign changed?
How does what sign change? They're squares. 1 squared plus minus 1 squared plus minus 9 squared.
We need to not just square this thing.
Magnitude. X squared plus Y squared plus Z squared. Yeah, right? No, but the square goes on each of these. Pythagoras. Yeah. You got that one? Right, what's the next one? What's the next one?
A times bracket B plus
A dot B plus C. Does that equal A dot B plus A dot C? Okay, try that one, please. Will we try it? Let's have a look. Oh, come on. Now, C. So first I'll do, what's the first one? A dot B plus C, is it? Okay. What's the A vector?
Well, 1 minus 9.
Okay. And then dot, and what's the B vector?
2 minus 3 minus 9.
And then C?
1, 1, 9.
Okay. Not minus 9? No? Okay. Right, so what do we do first? Well, first we must add. No, first add the brackets, the inside piece. So that would be 3 minus 2 and 0. 3 minus 2 and 0. And then when we dot these together, we get 3 plus 2, so that's 5. Now let's check when we have A dot B plus A dot C. So this will equal 2 plus 3 plus 81 plus 1 minus 1 minus 81. So that cancels that, that cancels that. 2 plus 3? 5. So in this one it is true.
Stephen, why is the first time you didn't multiply, like multiply A, multiply B, and then plus A multiply C?
Tell them.
Both marks.
What?
B O. Well, see,
No.
we use different ones in different countries. America is this one, and I always learned it in school. I thought it was Bomdas or something. What is it? B O. Anyways, it doesn't matter. You know, you have the orders. You always do what's in the brackets first. Is this what it's called? B O. Bomdas.
What does that mean?
First brackets, multiplication, division, addition, subtraction.
B is minus 9, not positive 9.
Doesn't actually matter because we'd still get the same result. B is what though?
Minus 9.
Yeah. Oh, which I did right there, minus 9.
And even, no, you, that's B, the B is 2, sorry. No, sorry, A, I'm talking about A.
A?
Sorry, C, what's the C?
119.
B plus C.
What?
No, I
Okay,
don't
is
know
it
that.
minus? Okay, is correct.
Yeah? Let's have a look at the last one here. Right. Try now 2D. See if it's true or false.
D? Okay.
There, the last one there in 2. Relax. You'll be fine.
Oh my god. The big group of different science, they start with classes at 1, Tuesday and Wednesday.
Lucky them.
Yeah, 1, 2, 3 today. 1 to 4, 6.
How's Those guys. Which group is this?
B group.
Who's in that? Give me some names I might know.
The one you said cigar. It's not cigar, it's Saga by the way.
Is it? Oh, embarrassing. Cigar.
Once you stand in front of the whole class, the people will remember you only by two reasons. By the rule for
Cigar. I thought it was cigar. No, it's Sagar.
It's not Sega, it's Saga.
Sagar.
Yeah, it's mean the name, the word.
I've already forgotten.
Means Falcon.
No, it-
What way?
So this group don't start until 1 o'clock today
Yeah.
and tomorrow?
No, yesterday and today.
Terrible.
Today 1 to 4, that's it.
How come? That's terrible.
The new, they don't give us this thing to us.
And that's because you're just engineers. Nobody cares about you. You need to be doing medicine, then people will care.
I won't care.
Yeah.
You interview, do this, do this.
They have a lot to be doing. Interviews.
Now, Sanford, that's it
Yeah.
for interview.
Huh?
They sent me email, I got another letter from them, and they sent me email.
Who sent you an email?
Sanford University.
For what?
They just asked me, want to discuss your course with you.
Oh, that's good.
So, but I can't go.
Why not?
It's difficult, like the visa.
You can have visa.
What grades do they want?
EBC.
And the only reason you're saying no is because of the visa?
Yeah, like visa, like
He lost his GNMA card. Not he, actually, he posted into the for re-entry.
Oh, well then he didn't lose it. If it was lost in the post.
They're saying they didn't receive it.
Yeah.
So now what do I have to do, Stephen?
You're in trouble now.
You should solve it before.
I
Because
have to get new one?
go to
They'll
the
support you.
go to like you should go there
Yeah, you need to go there.
and
Yeah, report it's lost.
that's your fault.
Don't tell, well even if it is their fault, don't tell them it's their fault. Because they're the ones that have to give you a new one, you know.
What happened with my room, like the previous roommate, he posted his re-entry, you know the postal money,
Yeah.
he posted that, so usually people don't, save the, the receipt,
Yeah.
so he posted it was like 10, after 15 days, he was like, he went to the, like,
Yeah.
for it, he said, I posted that, didn't get anything. He said, we have your file, but you didn't postal card, the postal money. Posted that. So he went home, he brought the, the slip.
Mhm.
Luckily he had it, he said, see, I bought this on that day when I posted it. So on that basis, they give him everything.
Yeah, GMIB are understaffed. They don't have enough staff, you know what I mean?
Yeah.
This is the real problem because they have to handle everybody in Dublin.
Not even down. Maybe more.
Dublin and maybe a little bit past Dublin as well. So, it's a capital city. It's a lot. It's a lot.
And they're the worst.
And you only have one office.
Yeah. Yeah. There should be at least two. One kind of north and one kind of south of
There
Dublin.
should be some at least online, so you don't have to go like 4 or 3, 5. You have to go GNIB now.
There's many ways to improve it. Yeah. Okay, nearly finished that one? The fault? Let's check it. Takin, can you call out the formula? What is it? Oh, hang on, sorry. Okay. What is it? ADB dot BC. Okay, let's calculate that first. Can you remind me what the A is? No.
1 minus 1 minus 9.
B
2 minus 3 minus 9.
and C.
1 1 9.
Okay. So AB is B minus A, isn't it? So that would be 1 minus 2, 0. And BC is C minus B minus 1, 4. Oh, sorry, I'm getting confused. 1 minus 2, 1 minus minus 3, 9 minus minus 9, 18. Is that right? Let's double check AB. 2 minus 1 is 1, minus 3 minus minus 1 is minus. Yeah, that's AB and BC. You know, B minus A, C minus B. So if I dot these together, 1 minus 2, 0, dot minus 1, 4, 18. That'd be minus 1 minus 8 plus 0, that's minus 9. Okay, KJ, can you read out the formula that's on the right?
B, C.
B dot C.
Yeah, B dot C.
Yeah.
Minus B dot B.
Oh, hang on. Minus B dot B.
Yeah.
Yeah.
Minus B dot C.
Yeah.
Plus B dot B.
Okay, so B dot C. Let's do that one. That would be 2 minus 3 minus 81. And then minus B dot B. That's 4 plus 9 plus 81. Minus A dot C. 1 minus 1 minus 81. Plus A dot B. 1 plus 3 plus 81, is it? No, 1, no, sorry. 1, huh? Yeah, 2 at the start just.
2 minus 3.
2 minus, no, plus, dude, plus 3 plus 81. Right, now the good thing is we can do some cancelling maybe, because this minus 81 will cancel this plus 81, and this minus 81 will cancel this 81. So we get minus 1. Yeah?
Why did you multiply C? Yeah.
Multiply C?
Yeah, last thing you multiply by C. The C, the letter C.
There's no letter C.
You just said, yeah, exactly.
No, it's C that, like, very line. Yeah.
Oh.
Come on. Right. Minus 1 minus 13, well, they cancel. Plus 5. Minus 14 plus 5. Minus 9. So this one here is true. Many of you said false. After you changed your mind.
True.
Let's have a look at number 3. Can I scroll down?
Yeah.
So in number 3, you want to find a vector, we'll call it x, y, z, or equals. And what you know is that or dot 1 minus 1, 2 should equal 0. And I also tell you that or dot minus 1, 3, 0 should equal 0. And actually it's a unit vector, so what should I write on the top? A little hat. So the first fact can make this equation, because remember or is x, y, z, so we can get x minus y plus 2z equals 0, and then here we can get minus x plus 3y plus 0z equals 0. There are two equations. Now, what will be the easiest thing to do? I think I'll just add them together, and you could then make 2y, yes, plus 2z equals 0. But there's not enough. You need to have at least one more equation. There's not enough with just two equations, right? So what is the third equation I could make?
We can make equation.
Well, what type of vector is R? So what is its length? Oh, come on, you did this literally yesterday. No, what is, how big? No, what is its length? What should its length be? It should be 1.
Yeah.
So what should its length squared be? Also 1. So in other words, magnitude is 1. So in other words, x squared plus y squared plus z squared should equal 1. Yeah?
Square root.
Yeah, but what's the square root of 1?
1.
So I squared both sides. Now, can you solve this? Is it possible? Do you have enough information?
Yes.
It is, because how many equations do you have? 3. And how many unknowns? 3. Yeah? Now, you need to be just a little bit careful about what you do here. So what I would recommend, let's see what we could do. How do we put these together? We can put, you could put these two together like I did to get 2y, wasn't it? Plus 2z equals 0, isn't that right? Yeah. Or if I simplify that, that's just y plus z should equal 0. Yeah? Now, I want to use this one. That won't be the best way to use that same thing. Z equals minus y. Yeah, now if you look here, if I have y plus z equals 0, and then if you just look at this one here, you could also say that x minus x plus, well, it's just minus x plus 3y equals 0, yes? That's all that is.
Y equals minus z.
That's what I'm thinking, y equals minus z.
Then x will be equals to
It's a bit trickier than I thought. I want to think the easiest way to do it. Yeah, okay, so what I'm going to do is, I'm just going to look at this first one here, okay? So you can forget about that, that's 0 set, so this piece here is gone. So what can we say x equals?
Plus x equals to 3y.
Yeah, you can say x equals 3y. Okay. So I can put that in here for x. So this is now 3y. This here is now y. Now I want to do something here with this one too.
Y equals minus z.
I could get here, I'm going to go for 2z equals y minus x. But what does x equal?
3y.
So that would be y minus 3y, which is minus 2y. So I know that x is 3y, and then what's z? Minus 2y. So if I put those in...
No, minus y. What's that?
Oh, sorry, thank you. So the 2's cancel, so it's just minus y. So this equation now becomes 9y squared plus y squared plus y squared equals 1. So you get 11y squared equals 1. Yes?
Y squared equals.
Yeah, so y squared equals 1 over 11. So y equals root 1 over 11. Now, because I know the y, do I know the x? Yeah. So what does x equal? 3 over root 11. And then because I know the x and the y, can I know the z?
Yes.
Yeah. So my answer would be x is 3 over root 11, y is 1 over root 11, and then
Minus 3.
7, the z would be,
Minus 3 over 11. Z
would it be?
minus 1.
No. Z equals what?
Minus 1.
Z equals y minus x.
Both of those.
So it'll be this one, 1 over root 11 minus 3 over root 11 minus 2 over root 11.
But also z equals to minus 1.
Did I say that where?
Because it's through z that is equals to y minus x.
Oh, sorry, yes, I say z equals minus y. So z and y are the same except for the sign, sorry. So this should be minus 1 over root 11.
Yes.
Now you can check that this is right because this should be a unit vector. So this squared plus this squared plus this squared should equal 1. And it does because when you square this you get 9 over 11 plus 1 over 11 plus 1 over 11 is 11 over 11, which is 1. Confirming that? What do you mean?
The question was on the book.
Yeah, this was number 4, I think. Wrong answer? At the back? What's the answer at the back?
0.904.
No, Fahad, no. This definitely has value 1. Give me. Trust me. What's the answer at the back?
1 over 3 roots 352.
What?
Oh my gosh.
Fahad, you forgot to square them.
This one here, of course, is wrong. Because next to it.
None of them have 1 over root 11.
Wait, is it right or wrong at the back?
I think it is right.
Hand it to me. Which number did I say this was?
4.
No, sorry, it's 3.
The same thing.
That's one.
Oh, root 44 is 211. 311. Yeah, it's the same. It's the same. Yeah, I know it is. Root 44 is the same as 2 root 11.
Root 44.
It's the same as, wait, 2 root 11. No, why does nobody believe me? Type in root 44. Yes. So you can simplify it to the same thing. I don't know why I didn't simplify it. Okay, go away.